Hello, and welcome to another episode of Cosmic Curiosities, where we explore the wonders of the universe. Today, we're going to talk about one of the most mysterious and fascinating phenomena in cosmology, cosmic inflation. Cosmic inflation is the idea that the very early universe went through a period of extremely rapid expansion, much faster than the speed of light. This happened when the universe was only a tiny fraction of a second old, and lasted for a very short time, but it had a huge impact on the shape and structure of the cosmos. But why do we need such a strange and dramatic scenario? Well, cosmic inflation was proposed to solve some puzzles that arise from the standard Big Bang model. For example, how come the universe looks so smooth and uniform on large scales, even though different regions of space were never in contact with each other? How come the geometry of the universe is so flat, even though any tiny deviation from flatness would have been magnified by the expansion? And how come we don't see any exotic particles called magnetic monopoles, which should have been produced in abundance in the early universe? Cosmic inflation solves these problems at a stroke. In its earliest instance, the universe expanded faster than light. Light's speed limit only applies to things within the universe. That ironed out wrinkles in its early chaotic self and meant that even now far-flung parts were once in close contact, so could swap heat. It also stretched out any curvature in space, making it appear flat. And it diluted the density of monopoles and other unwanted relics, making them extremely rare or non-existent. But what caused this inflationary burst? The answer is not fully known, but the leading idea is that there was a new kind of quantum field that filled all of space and time. This field is called the inflaton, and it had a very peculiar property. It had a lot of energy even in the vacuum. This energy acted like a repulsive force, pushing space apart with incredible speed. As the universe expanded, the inflaton field slowly decayed into ordinary matter and radiation, ending the inflationary phase and giving rise to the hot and dense state that we call the Big Bang. The inflaton field also had another important consequence. It created tiny quantum fluctuations that were stretched by inflation into large-scale density variations. These variations became the seeds for the formation of galaxies and other structures in the universe too. By studying these fluctuations in the cosmic microwave background radiation, which is the leftover heat from the Big Bang, we can learn more about the properties of inflation and test different models. Cosmic inflation is one of the most successful and influential theories in modern cosmology. It explains many features of our observable universe that would otherwise be hard to account for. It also opens up new possibilities for what lies beyond our horizon, such as a multiverse of many different universes with different physical laws. However, cosmic inflation is not without challenges and controversies. Some physicists question its validity or necessity, and point out that there are still many unknowns and uncertainties about its origin and mechanism. Cosmic inflation remains an active area of research and debate among cosmologists. Thank you for watching this episode of Cosmic Curiosities. If you enjoyed it, please like, share, and subscribe to our channel. And if you have any questions or comments, feel free to leave them below. Until next time, stay curious.